Hello, I'm Agnieszka Szczerba, the co-host of the Sherpa Search on Tech podcast. Today we have a very special guest, Dror Haor, a VP of Artificial Intelligence at SeeTree, an intelligence platform for trees. But before we start the conversation, I would like to say thank you for all your subscriptions and for all your likes. And of course, I'm asking for more. So if you haven't subscribed to the channel, this is the right moment to do it. Coming back to the conversation, this is a great topic and a great guest because we will talk about precision farming, about use of robotics and artificial intelligence in agritech.
Dror, how would you describe what precision farming is?
Okay, so great, thank you. So maybe let's start. We can start with a little like background on what agriculture and farming is coming from. So you know, by 2015, you know, the population of the world is going to double itself, and we're going to consume more than double of the amount of food we are consuming today. There will be about 10 billion people on Earth, and many of them will move to a bigger city. Everybody wants to move from the farmland to a bigger city. So the consumption per person will be much more. So it will be very effective. On the other hand, there is a very large trend of water levels. So water levels are getting reduced. We need more power to generate more fresh water. And the environment is degraded. Climate change, everybody knows about it. So there's many challenges that farmers have, which will lead to from like several decades ago, starting to go and find a more precise way to do the farming to improve the amount of operation to yield, the ratio between operation and yield. And what happened actually is that there comes many tech company came into this domain and added more sensors and more knowledge and more data to build this what we call the agriculture 4.0, which eventually brings the ability for the farmers to enable them to do more with less. And in order to do this, many companies use different sensors and different computation and mathematics and AI, of course, to enable more features and more accessibility to features to those farmers that before we couldn't have. And precision farming is exactly what they need. They need to be able to detect every crop. And on the world of where I work, it's more on the tree level. So we need to be able to bring each tree the optimal treatment for it. So whether it needs a specific amount of water, it needs specific amount of fertilizing or spraying, if it has some specific disease which those trees around it doesn't have. So for in general, if we would be able to bring precise treatment and measurement to each tree or each entity in the field, in the farm, we'll be able to do more with less. And this is what's, in my view, the precision farming is.
What is the role of artificial intelligence in precision farming in general?
Yes, so artificial intelligence, it's a big word coming from the machine learning domain, where we want actually to incorporate some human intelligence into the machine to be able to do some work that is similar to what the human does. But in order to understand what artificial intelligence can do, we need to understand what are the sensors that it actually uses. So, for example, in agriculture or farming, I can split it to like two major part or types of sensors. The first one is like tangible sensing or physical sensing, where farmers can like add sensors that were put in the ground, or sensors that measure the amount of water that comes through the pipes and stuff like this. The stuff that you actually put and that touches what it's sensing. In that sense, you can measure the soil's humidity or other parameters. You can understand how much water is gone into each field, and you can measure the temperature of the area. Okay, stuff like this. The problem with all of those is that you have some ways or means to understand what is the status of the soil or the water or stuff like this, things that will affect the plant. Okay, so you can really understand what will happen in advance. But the problem is that those types of sensing have problem being very precise. As we said, we want to go to precision, so we need to go and put every sensor like this on every tree. That could be very expensive, for example. And for example, there is things that are not even possible to measure the amount of water that goes for each tree. So there are things that are not possible with those type of sensing. And the other type of sensing is remote sensing. That's where you go and for example, measure or image an area of the farm or the entire farm using RGB imagery or multispectral imagery or LiDAR imagery or radar imagery. So all of those are remote sensing types of measurement. And the advantage of this is that you can go and measure per tree or per very precise unit of economics, but you need to go to do this, and you need to do this in large scale. Okay, so you can take, for example, a plane or a drone that can scan a very large area and identify illnesses, for example, or amount of water in the ground if it's visible. So those types of sensing are more relevant for large-scale imagery or large-scale treatment or monitoring. But it has the issue of measuring after the effect. Okay, because we're measuring the tree at its status right now, and if it's already affected, you came after it is already affected. This is actually can be mitigated by measuring a long time. So using the remote sensing and measuring it a long time, and actually get more of the trend of the tree, or the tree of the crop. So you can actually detect degradation or detect improvement of the tree, and that way you can do predictions. We work at remote sensing domain using and incorporating this with AI. And AI, based on that types of sensing, AI can do a lot to help crop monitoring for your question. So for example, AI can detect the amount of trees in a farm. you can detect the amount of dead trees in the farm. Sometimes the farmers and the managers doesn't even know how many dead trees they have in the farm, because they're sending their operation personnel, and they do not return back with this information of how many dead trees, and eventually you have a large percentage of dead trees. You can detect the sizes of the trees, for example. This is something very important for the farmers to understand. How does the trees size changes across time? They expect some kind of growth. If it's not as expected, they might want to irrigate it and plant another one. So this is an important feature that AI can bring. Of course, AI can give monitoring of diseases. So there are many diseases that can be seen from aerial or ground imagery that can be also be done. So all of those, as I like to look at it, everything that a human can do, AI can do, and also almost all the things that the human can do, and then once you have an artificial human in there to help you, you can do a lot more without and with less personnel in the field. So this is really how AI can really help farmers and farm managers to do this stuff.
This sounds amazing.
Yeah.
But it also sounds that this is a quite complicated ecosystem of sensors, of IoT devices connected to some cloud application backed by machine learning algorithm. My question is thus, how it is with the data, with data collection, to make that the data is reliable, which are taken from various sensors, and how to make this data, let's say, as clean as possible.
Exactly. So that's a great question. So again, for each type of sensing, we should have like a specified or dedicated cleaning system. And really, as you pointed out, the problem is using those sensors in scale. And in order to scale, if you have sensors that has to be in the ground, like placed in the ground and measure the soil temperature or soil humidity or stuff like this, you need to be able to understand your area. You need to be able to understand where to put those sensing devices. You need to make sure that they are still fit and they are still working after 2 or 3 years, if they work under a very stressed and weathered situation. If you're working on remote sensing, so you need to be able to take a drone, for example, and fly it over a very big area. So sometimes drones can do some areas, so you need to do take it back and then move to another place and start running it from there. So that's a problem that sometimes is solved by using airplanes or that takes imagery devices on top of it and can scale and image very large areas, larger than what a drone can have. And even above that, you have imagery from satellite, for example, that can take very large areas. So each of those has its own pre-processing techniques, enhancement techniques. So, for example, satellite imagery is not as accurate as drone imagery or imagery that is taken from the ground, like using a tractor or stuff like this. So every type of sensing needs its own dedicated treatment. And here also AI can come into play, where AI can actually work on different scales using the same model, because AI can eventually, after trained, of course, can act like a professional agronomist or very close to it. And when you give an agronomist those type of signal, as a human, you give them different types of signals, different types of imagery. You can handle both imagery from the ground and imagery from the air. And if you train this artificial agronomist well, you can do it without making a lot of mistakes. And this is where AI can actually enable more to the farmers.
Is it easier to apply this kind of technology to grain production than to trees, or is it equally complicated?
So I will say it needs some kind of experience. People in this field are mostly been to universities and learned this for several years. There is some type of understanding in this field that you need to understand the data and the type of data that you're working with in order to bring a good product. Today there are several companies that try to make it even easier to build the computer vision models that will be very accurate per some kind of indication from humans. So the human can bring some kind of we call it a label set. Okay, you can take a number of images and say, this is a set of diseased trees, and this is a set of healthy trees, and from that the model can actually learn and scale. So whenever you give it a new image, it will say whether this is a diseased or a healthy tree. Many times we see that trees are very different entities than differences between cats and dogs, for example, which is like the basic example that someone gives for the machine learning. So comparing dogs and cats is actually very complicated, but it's for human it's really easy. But from the other hand, to detect a diseased tree and a healthy tree is sometimes very tricky to human. So for machine is even more complicated. So to do this, we need to use more complicated AI systems to enable accurate estimation of and detections of parameters of the trees.
So helping with AI to fight pests and fight tree diseases also helps reducing greenhouse gases, doesn't it?
Yeah. So let's say today, for example, farmers most of the time, in order to fight pests and diseases, they spray a lot, and they spray the fruits, and they spray the trees, and they spray the ground, and it's really contaminating everything. But they spray a lot because it's the only way they know how to do it. And if you were able, as I said, to have a specialized expert agronomist look at every tree you have and say, this is a tree that needs this amount of a spray, or this amount of spray, and be able to optimize and give a precise measure of how many spray you need to account for this disease or pest that this tree has, and you can do much better. You can reduce the amount of contamination to the ground. You can increase your profitability because you're spraying less and your costs are less. And you can do this even not with spraying for diseases. For example, if there is some kind of weakness of the tree, so the tree needs to have some kind of a fertilizer. This also can be identified by some kind of an expert agronomist that go through every tree, and that way we can actually fertilize specific for each tree. So these things are happening, and these things are really helping farmers do more with less. And I think that's a great way that AI can bring to the farmers.
So AI makes agriculture way more bio, as we would say.
Exactly. This is one of the things that is really amazing, because we can actually help not only the farmers to be profitable, also we can help the environment itself.
How much is it affordable right now? All this kind of intelligent agriculture technologies to be applied in third world countries. Not yet, or already?
It's already applicable in all around the world. The cost is much less than what you actually gain from using it. And this is something, you know, as a company, we always make sure the customers has a good ROI, return of investment from our products. So everything is gone through this funnel that we need to make sure that the customer gain, and they actually gain a lot more than what it's paid for this. And we're working more and more to build software and build algorithms and build AI machines that will cost less and will be able to do more. So, for example, one example will be take satellite imagery, which are very cheap but has low resolution, and using them to estimate, to get a clearer view using generative AI, a more accurate view of the trees themselves. So you can actually get something very similar to drone imagery based on the cost of satellite imagery. So this is stuff that we're working on that can reduce much of the cost for the farmer and bring the same value as a drone, for example. So we're working every day to improve those things and enable more and more farmers to join this agriculture 4.0. Yeah.
Could you present us more SeeTree, the company you work at, as it is one of the world leaders in this intelligent agriculture?
So yeah, so I act as VP of AI at SeeTree. SeeTree is an agriculture company, and we are in the business of intelligence. We are measuring, as I said, we're measuring farms and forests. We didn't talk about it yet, but we also work in forest. And we arm the farmers and the foresters and their managers with remote sensing and AI tools to enable them to do more with less. And we do this by taking images from the air, from the satellite, from the space, from the ground, and we take images from all around the area using different types of sensing devices to bring a complete solution for the farmers to manage and operate their farm or the forest as best as possible. And we do this by providing them with a digital platform that they can actually see every point of their farm. They can look at every tree, and you can see for each tree or each area of the farm where do they have weak areas, and where do they have diseased area, where they need to irrigate more, where do they need to fertilize more. Everything we talked about, this brought to our customers through our platform, which mostly is enabled by AI.
This is amazing. The last question on my part: how much is robotics involved in agriculture 4.0, and are there any particular challenges that robotics face?
So I think robotics is still in its beginning. We see a lot of initiatives and new companies that comes into this domain. It has to be more established. So I think that before the robotics, the massive of the robotics will enter, I think there will be more like a retrofitting of specific tooling. So, for example, we have spraying that are connected to some tractors. So those spraying machines will be automated before there will be robots that will do automatic spraying. But things are really evolving there, and I think like in the main goal of the future is to use robotics as much as possible to enable more with less, and actually give the ability for the farmers to bring more from their area into a yield. And this is something that is like the holy grail for every farmer, and they will need to eventually, and it's really hard for them to do this move, but they will need to do this move eventually to the technology, to the robotics, to the big data, to the remote sensing, and all the things that we're doing, because eventually it brings it will bring them what they really need. And from what the point that we're working at, we're trying to build a connection between the data that we are collecting using this remote sensing imagery to the robotics, to enable the robotics, to give them the opportunity to work with good data, to work based on good data, and do their work as best as possible without mistaking.
Dror, thank you so much for telling us all this. This is absolutely amazing.
Thank you.
And it's great to see that AI is not only about, asking ChatGPT to write a poem in, I don't know, Shakespeare style, or Mid-Journey to draw some, surfing cat.
Exactly.
But it solves real world problems and really helps. Maybe it's a big word, but humanity, because we all need food. So once again, a big thank you for having you.
Thank you for having me in.
And hope to see you sometime next time.
Exactly. I'll be happy to be here again.
Thank you so much for listening to Sherpa Search on Tech. If you have enjoyed the show, please subscribe to our show wherever you listen. Thanks again. The Sherpa Search on Tech podcast is a production of Sherpa Search, an executive search firm specializing in the tech industry, helping hire the right people for expert and managerial positions, and advising how to build and develop long-lasting, high-performing IT teams. If you would like to learn more, reach out to us at maciej.szczerba@sherpasearch.tech or visit our website sherpasearch.tech. See you next time.